Thank you, Kabul, for the introduction, and good morning, everyone. Before starting, I want to thank all the GDevCon team for creating such an event and to give me the opportunity to present for the third time in a row. So thank you, everyone. Before starting to dive in the open source topic, a really quick who am I slide. I'm Olivier Jourdan. I'm programming with LabVIEW for more than 25 years now. I founded Wovalab in 2018, and I'm a board member of the DQMH Consortium. If you want to know more about me, just come and discuss with me, and there's LinkedIn, all these things. Now, this talk is not going to be a technical talk. I want to talk about open source projects made by LabVIEW developer for LabVIEW developer. I want to share my personal experience. I'm not an open source guru. Probably you know more about open source than me, but I really want to share one experience I had with open source project. And if 2 or 3 of you at the end of this talk start thinking about starting an open source project, I would be really happy. So, what is open source? What's the meaning we have in mind when we are hearing open source project? First, I think it's I'm going to use a tool for free, and a tool, it could be an API, an application. I have access to the code, I can modify the code, I can add feature, I can fix bug. And around this project, I have a community of developer users. And this is something that is more on the side of the user of an open source project. And probably we all use open source project sometime in our development journey. But the real question here and the presentation is about how to develop and maintain an open source project and why I should start open source my code or not. First reason to create an open source project is because you are nice, you want to share your code for free with all the LabVIEW community. You probably also want to have kind of a team working with you, have contributions, feedback, beta test, code contributions. And when you are working alone, it's a good thing. And open source can fix this issue of the team, the team working. As a business side or as a developer, you may want to communicate on your project, and probably all the code you are doing for your company or for other companies are under some kind of NDA you can share with other people. If you have an open source project, you can share all the code, you can talk about it, and it's again a good thing to start an open source project. And you may want to build a business relying on open source project. This is something large companies are doing. Take Red Hat, it's a Linux distribution, open source obviously, but business is made with this open source project. In my talk today, I will share an open source project, small open source project I did. And I did it for the 2 first reasons. Because I wanted to have this project used by many developers, and I wanted to have contributions. It turns out that I can do some marketing with it today. So that's the cherry on the cake. So the real life example. So I want to show some code, even if it's not a technical presentation. But I really want to make obvious that what the open source thing give me during the process of the development of this project. So it's a small LabVIEW API, and the issue I wanted to solve with this API was to execute the code periodically using an helper loop. So being sure that my code is going to be executed every 100 milliseconds, for example. An helper loop for DQMH user is this third loop you can add at the bottom of the DQMH module. But an important note, helper loops is just a name to describe a design. You can use what we call as a DQMH user helper loop in any kind of architecture. And yes, I know there are many other ways to execute code periodically, but again, this is not a technical presentation. What is an helper loop? Basically, it's a while loop, an event structure with the timeout case, and you are going to set the timeout value with a constant, and the code is going to execute the timeout every 250 milliseconds in these examples. But there are pitfalls, and you need to know them if you want to execute your code periodically correctly. The first pitfall is that the timeout countdown starts when the event structure executes. So the code you are going to execute in the timeout case, it's going to take some time to execute, and this time is going to be added to the constant of the timeout. So this code is not going to execute each 250 milliseconds, but each 250 milliseconds plus the time the code took to execute. The second pitfall is that if you add an event in your event structure, each time this event is going to be fired, the timeout is going to be reset. That's what is that? Excuse me. that's the way the timeout case is working. So it's the event structure is working well, but if you want to use it to execute code periodically, you need to have that in mind. So I decided to create an API so you can use this helper loop thing to don't mind about all those things and use it without knowing exactly how an event structure is working. Why I decided to create this project, this API as an open source project. I've been knowing about these pitfalls for a long time. So for my customer, for the application I've been writing for my customer, I put some code to handle those pitfalls. But there was no standardization over my different projects. I never took time to create a reusable API. So yeah, it was not that good. And at the end of 2023, the DQMH Consortium, at the DQMH Consortium, we were working on the last version of the DQMH framework, and one of the main feature we were adding was the tool to create helper loop automatically. So DQMH users are now able to create helper loop really easily. So it was the thing that triggers me. I need to provide something to help DQMH user to use helper loop correctly. What did it mean for me to open source my code? First, I needed to create an easy to use API. Remember, one of the goals is that any LabVIEW developer can use the project. So if it's difficult to use, probably there will not be a lot of users. The same way, I need to provide a documentation and provide a really easy way to install the API. So I need to provide a package, and thankfully, on VIPM.io, you now have, for 4 years ago now, they introduced the community repository. So anyone here can really share their code really easily with all the LabVIEW community. And that's a really important point for me. In my opinion, open sourcing a project, it's not just making it available to the public. If you do that, probably no one is going to use your code. You need to do more than just sharing your code. At the end, I made this API. As I said, really small API, 5 functions. And with those five functions, you can fix all the pitfalls I talk about, and you replace the constant by this object that contains every information needed to run the helper loop correctly. You can add any event in your case structure. It's not going to mess up with the periodic execution. Why? No, it's not a broken wire. You know, it's blue because it's the same as a timeout, and you can change the aspect of the wire of an object if you don't know. But I'm sure you know that. How open source helped? Feedback. I really had a lot of feedback. During the development process, because it was an open source project, it was really easy for me to ask to my network of LabVIEW developer for feedback. Is it a useful API? Is it something easy to use, in your opinion? And so when I released the first version, I was really confident to be really close to the truth about the API integration. And when I released the first version, I also had feedback from users. And one feedback I need to mention was Petru. Thank you. Petru sent me 2 pages of review, of code review of my API. And it was plenty of really good remarks, possible bug, spelling, anything that really led me to bug fixes, integration improvement, and new feature. Remember, the only goal of the API at the beginning was to set a period and have the helper loop executing at this period. But at the end, I figured out it was really easy to give execution feedback to the user. Is it the first execution since I started the helper loop? Is my execution is late? My code in the timeout case takes too much time to execute at the expected period. Having some information about the current number of execution, and with this value, it was easy for me to add a way to stop the execution of the helper loop after a certain number of executions. So I improved the initial API I had in mind. And at some point, someone used the API and found a major issue. Something I never think about. And it just, and I don't want to dive too much into this issue, but it checked that if you are running the code as a 100 millisecond period, and you are executing 100 loop, the execution time expected should be 10 seconds. Simple math. But obviously, it was not the case. the time was greater. And on the top graph, I plot the difference between the expected time and the real execution time. And you can see with the version 1.2 that we have a drift after 10 seconds of 30 milliseconds. We fixed the bug. And with the version 1.3, we keep the drift really close to 0. But we had discussions about this issue, and it led to a new feature. And now there are 3 modes to handle the late executions. Again, I'm not really going to dive into that too much, but you can see that each graph is representing the same execution with 3 late executions. And you can see the drift measurement, and depending of the mode, the drift is different. On the first graph, we try to recover from any late execution to keep the drift close to 0 milliseconds. And on the last one, you have the same behavior than using the metronome function. So it's always a multiple, it's on the middle graph, it's a multiple of the period. What is the project status after 9 months? If we go to the IPM.io, the page of the API, the first thing I really like to see is the contributors list. I'm working alone, but on this project, I had a team of 5 people helping me improving the tool. So that's really, that was one of my goals at the beginning. Check. And I would like the code to be used by a developer. There are more than 300 downloads. I know that it's not 300 users, but we can imagine that there are 20, 30, 50 users of the API. And it's still more than all the application I'm doing for my customer. Test benches are used by 1 or 2 end users, 10 depending, but yeah. The second goal was to share this code with the community. Seems to be reached. What I get from open sourcing this API. First, I need to say that I had constraints. I need to polish the API to create a better documentation. I wouldn't have spent this time if I just made this API for my own usage. But those constraints led to a better product. And the benefits of open sourcing this API was the fast feedback. Same, bug fix and improvement really fast than doing your code on your side only for you. A better tool, and on a business standpoint, I now have a really good tool for this, so I increase the customer satisfaction. So I really improve a tool I'm using almost every day in my application. Well, not every day, but I'm using it in all of my application. If I sparkle things for you, I have an API I could start open source. Here are some advice if you want to go that way. First, start with small projects. It would be easier. Then you probably need to learn the basics of open source management. Shameless plug, it's too late for the vote, but I have an huddle at 2:45 to practice contribution to open source project, merge request, fork, all these things. Think about the license you use for your open source project. Probably Oli Wakno would be the guy to discuss about licensing. You did presentation, if I remember. Yeah, but you know more than me. But it's an important thing. Don't wait to have the perfect project to open source it. Let's go, share your code. Don't wait. You will never release a product if you want to release a perfect tool. And provide a good developer experience. You want feedback, you need to have users, so you need to polish this part of your project. One warning. As I said at the beginning, open sourcing a code, it's not just giving the code and, yeah, let's go contribute. No, there are lots of things. Handling contribution to an open source project is a lot of work. You need to discuss with the contributors. You need to make the project management. You are the project manager of your code. You are the maintainer. So you need to handle that. No pain, no gain. If you are not giving, you are not going to get things. As a conclusion, in our LabVIEW world, we have LabVIEW that is a proprietary application. We have things like DQMH. It's closed. It's not an open source project, DQMH, but it gives you the control of all the generated code. You can have Antidoc. It's another project I'm maintaining. It's open. We have access to everything, but it's very large. There are dependencies with other products, complex. And you have this helper loop timing API I showed you, open and small. I really think that we have something to do there. We heard about NI, initiatives about open sourcing the icon editor. Probably we can have more small projects coming from LabVIEW. And we have all the projects we can do as a LabVIEW developer. So we need, I think, it's my opinion, but we need more open source projects. For small things, I'm not saying reinvent everything, make big things, but small API are really useful. And if we are all working together to improve those API, we all benefit of this. But we also need to learn how to maintain, to develop, and contribute to open source projects. So that's the end of my presentation. Thank you for your attention. We can continue the discussion on Discord. And I have two others this afternoon at 2:45 if you want to know how to contribute to an open source project. And Friday, 4 p.m., if you are still in shape, if you still want to do some LabVIEW code, it's really open. If you have questions on one of the projects I'm maintaining, we can dive in the code, do a code review. We can actually do open source contributions on these projects if you have questions. Thank you.
Are there any questions from anyone? Yeah. Will you be at the back?
Yes, so thank you for your presentation. I was wondering if you have any ideas at all about, as a developer, getting at least like some money to go to events like this to promote your tool on either open source or closed source contributions? Like donations or sponsorship or...
What could help open source things?
Well, it would help development, I think. If people would actually donate something to tools like yours.
For my project, I have a Patreon. You can donate. Some Petru is donating. Thank you, Petru. Again, it's just $5, but still, it's encouraging. Other companies have contributed, HAC, for example. I think the difficulty as business point of view is that you need to invest time on those development. And yes, time is money, and the time I'm spending on those tools, I'm not spending on customer projects. And yeah, if we could find, and for all the open source projects, if we could find a way to get money and to save time for development, it would be really great. I don't have any solution. I tried the Patreon thing. I know that the G Central tried things, but I think it's not working. My Patreon thing is not working that much. But yeah, I don't have the right solution. I tried the Patreon thing, but...
I think it's more a community problem, that it should be maybe more normal to donate if you benefit from a tool like
the difficulty is, my opinion is that the company should give. I have two companies that are donating, HAC and JKI, because we are developer and we are not going to give money for the developers that are working for companies. I'm talking. Most of the LabVIEW community is in this situation. I'm not seeing myself giving money to a project I'm using for my boss. I would like the company to be aware that their tool are relying on open source project, and if they want those projects to be maintained over the time, they should probably give some bucks every month to encourage the development of this. But yeah, this is a real interesting point to dive into.
Cool. Thank you very much.
Thank you.